This short video will introduce you to a simulator environment for levers, torque, angles, load. So here you see a basic lever system. We have a pivot point, we have a place where our load is placed, and we have our effort. Let's take a look at how this our measurements that we have to look at. We have a mass of 5 newtons that represents this blue box. WP is the distance between where our load is and P, the pivot point. X represents the angle between the lever and where the load is. PS is the pivot point, the distance between the pivot point and where our effort is. Y represents the angle of effort. And then, of course, the spring balance reading here of 4.52 newtons. So you'll notice that as I slide the pivot point, numbers change. Notice the mass didn't change. However, the distance between the work and the pivot point got smaller. Degrees here stayed approximately the same, went down a little bit. But notice here that we have a difference, a large difference in our spring balance reading, as well as in our distance between pivot and our work, or our effort. And I take that back the other direction, you'll notice that the numbers change again. So what we're going to do is you're going to play around with this particular simulation here and just see if you can determine any relationships at all, general relationships that exist. You'll notice in this case as I move my pivot point and I change this angle, you'll notice that my angle of Y here is 34.4. I'm getting 2.3 or 2.13 newtons. And if I change that to a vertical, I've got 1.20. So you can see that this is more efficient than this. However, it would be very difficult to have muscles attach in this way. So your task is to try and simulate how muscle attachments might work with this. Now, periodically, you might be working with this particular tool, and you'll notice that it freezes. At some point, you can't get it to move. Simply click on the refresh button on your browser, and you're back to where you began. All right, so go ahead and explore this tool. Remember, you are looking for general relationships that might exist between angle, distance. This would represent the attachment where the muscle attaches on the bone. And remember that we don't really have any systems that have a pivot in the middle, so we need to put the pivot to one side or the other. And let's see what you can come up with and bring that information to class.